I come because I like to learn about what is going on in the industry. I like to hear from the contractors, especially because being an engineer, sometimes it's good to learn from the contractors what innovations they're coming up with, and obviously to meet with other folks and see what they're working on.
This conference, it's probably the most important event during the calendar year, so you cannot miss it. Because here you can meet a lot of people, contractor, supplier, competitors. So as I said, it's the most important event in the calendar for foundation business, and it's too important to don't be here, let's say.
We come because we get a lot of exposure to people who use our equipment. Camaraderie, a lot of camaraderie. Even with our competitors, we come out and we rub shoulders. Everybody knows everybody. It's just one big happy family.
Well, it depends on whether or not you want to continue learning. If you got a desire to continue to learn, then you need to be at DFI.
The good thing about this conference, you can meet a lot of people over and over, so you can make a very good connection with the industrial people.
Networking's huge. There's so many people here, just from different parts of the country and the state and the world even, and just seeing what processes they're using and their design methods and their equipment, and just really a lot of exposure, and also getting connected with those people for potentially future work, future jobs.
Come join us if you're interested in anything in this industry. This is the place to be. This is it.
Very good evening, everyone. Warm welcome to one and all to DFII of India Groundwork 2024 series, Webinar 3. So before we start the program, here are a few quick instructions. Recording of this webinar is strictly prohibited, and the online recording of this webinar will be available on DFII of India YouTube channel in approximately 2 weeks. And also participation certificates for the student attendees will be emailed in approximately 2 weeks. So you can ask your questions for the presenter anytime during the presentation in the Q&A box as shown on your screens. So coming to the registrations for this program, so we received more than 375 registrations from almost 16 countries as shown on the screens. Once again, I welcome you all who is joining from different parts of the world. So the sequence of today's webinar includes the introduction of the speaker, Mr. Tarun Kumar, and followed by his presentation on the topic, quality assurance and control measures in construction of board cast-in-situ pipes. Then we'll have a 15-20 minutes Q&A session, and then I'll brief a few details about the upcoming events of DFII of India. So without any further delay, it's an honor to introduce today's speaker, Mr. Tarun Kumar, Assistant Vice President and Head Quality Assurance, ITD Cementation India Limited. Mr. Tarun Kumar is a civil engineering graduate from Jadavpur University with more than 35 years of experience in construction industry, managing construction activities with a prime focus in quality assurance and control in building, marine, industrial, and urban infrastructure segments. He worked extensively on quality management, including handling of high-performance concrete. He designed and developed high-strength and high-performance concrete of various grades with sustainable measures to achieve longer service life using chemical and mineral admixtures. He presented technical papers in various national and international conferences on durable concrete, self-compacting concrete, and quality control techniques related to deep foundations. His current studies include behavior of plastic concrete and temperature control measures for mass concrete. We heartily welcome you, Mr. Tarun Kumar. Now I request you to kindly share your screen and start your presentation. Thank you. Sir, you are muted. Sir, we can't hear you. Can you please? Yeah. Okay.
Yes. Now it is okay, I think.
Yes, yes, sir. Good to go.
I thank you all for sparing time to attend this webinar for an issue which is quite relevant, common, but yet important and critical as well, because it's a matter of foundations. So today we'll discuss about few things about the foundations, and there's various types of foundations. Then we quickly move to the quality assurance practices related to construction of the pile, as well as common problems that you face during the constructions. So to have an introduction, pile it's a columnar element in the foundations which normally transfer the load from superstructures through weak compressible strata or waters. In case of marine piles, it's
Excuse
passing
me, sir.
water.
Your screen is not shared in case you are displaying anything.
It's not shared.
No, not yet, sir.
You put me this screen share টা কোথায় গেল জানো? কোথায়? এটা DFII পুরো আসে না। You are showing in slide mode.
Still, it is not in the slideshow mode, sir.
Right, if
Yes, yes, yes. Now we can see. Please continue, sir.
So there are various types of pile: steel, then precast driven cast in situ, board cast in situ. Out of all these things, the board cast in situ are most commonly used. We have a specialized equipments nowadays, tools for the construction of these piles, but the whole process has to pass through a stringent quality control checks to ensure the quality of the product at the end of the day. So we maintain an extra high class quality assurance plan right from the procurement of the raw material to the end of the pile construction, so that the integrity of this pile is ensured. Now a little bit about the load transfer mechanism. Based on this load transfer mechanism, these are classified in two types: axial load transfer and lateral load transfer. In axial load transfer, the vertical component of the load, it transferred through skin friction, as you see on the right side. When it goes down, the friction acts upwards and the pile takes the load. When the full friction is mobilized, then the load is taken at the base. So the first part is skin friction and the part 2 is end bearing. On the lateral load, when the pile is loaded, it presses the adjacent soil so that it gets compressed, and both compression and shear happens in the soil mass, which ultimately resists the lateral movement of the pile. So in general, all piles are driven or bored in ground. So broadly, there are two categories. One is called displacement piles. All type of driven piles are displacement piles. This could be Large displacement could be small displacement. Large displacement means driven piles with a shoe at the bottom, and the small displacement could be hollow tubular piles. So first is the displacement piles, and second category is the replacement piles, which is board cast-in-situ piles. Now let us simplify a little bit based on the load transfer mechanism and based on the construction methods. So based on the load transfer mechanism, it is end bearing, is friction, and combination of end bearing and friction, 3 types. Similarly, based on the load transfer construction methods, the driven piles, then board cast-in-situ pile, aggregate pile, as commonly known as stone pile, stone columns. So these driven piles are displacement piles, board piles, aggregate piles, and replacement piles. Now, how the load transfer mechanism takes place, as right now I have said, for the end bearing, the type of piles rest on this solid layer, the rock or the dense sand stratum. For friction pile, this pile transfer the load of the superstructure by using the frictional force, and there are pile which has got both components, skin friction and end bearing, partly skin friction, partly end bearing. So this is one of the construction method, driven pile, where pile is driven by a hammer of a suitable capacity, which ultimately push the soil sideways and compact the layer, and ultimately increases the bearing capacity. This is board cast-in-situ pile, 3 stages we have seen. The first stage, you see the boring by auger. Stage 2, see by when the boring is completed, then lower the steel cage, and stage 3 is filled with concrete. This is board cast-in-situ pile when the hole is dug into the ground and filled with the concrete with the steel reinforcement. Then aggregate pile, this is similar to a board pile. There is no reinforcement. You dig it in a hole and put it aggregates into the pile, which pushes sidewise and densify the soil, increasing the bearing capacity. Various tools we commonly see the rigs. Nowadays we are using the rotary rigs, hydraulically operated. In earlier days we used to have a mechanical rigs in tripods form. Then for the placement of concrete we use tremie pipes. At the top there will be a funnel or hopper. Then for the support fluid circulation we need a tank with pump. It's called the bentonite tank. Then crane as a lifting device for shifting of materials here and there, even for the lowering of the cage. Then concrete batching plants for the supply of concrete, production and supply of concrete. Transit mixture is for the transportation of the fresh concrete from the mixing point to the placement point. These are the major equipments that you need. Other than small accessories would be required. Now let us turn our focus more on the today's subject, that is board cast-in-situ piles. Now, what are the various stages? Just I have put it down over here. The major stages till completion of a pile, right from the survey. First, you do the survey to find out your points where actually you need to install the pipe. Once it is finalized, then you start with the driving of a casing or a liner. It could be removable type, it could be permanent type. In case of permanent type, longer casing, it could be jointed segment by segment. Then it goes up to particular depth where it has got full fixity and the sides of the borehole is stabilized. After that, you start boring with the help of support fluid, where the sides of the borehole are stabilized with the help of support fluid. Could be bentonite or could be polymer. Now, once the boring is over, then washing or cleaning of the pile base so that the latent debris, bigger pieces of soils, etc., do not remain at the base of the pile too. So once base is clean, then you put the reinforcement cage. In case of longer pile, it could be in segmental manner. If it is more than 10 to 12 meters, then once it is completely lowered, then we make arrangement for the placement of concrete through tremie pipe. We call it tremie lowering, then concreting. Now, all these stages, there are various checks. What it should be, what I am getting, am I getting the right parameters or not? If not, what I should do? Various stages, there is a lot of checks of various characteristics. So let us see stage wise. First, you need to do the survey. Say, little bit simpler. You need to have this calibrated instrument, which will put the point on the ground. Then you measure the levels, mark it, put your reference points, so that you are ready for the driving of the first casing. So your checkpoints would be the calibration, ensuring proper location, ensuring coordinates, and ensuring proper documentations. Then comes your driving of temporary casing or the liner. You drive the casing. Here in the photographs, it shows a temporary casing. It could be of 3 meter, 4 meters, something like that, based on the soil profile. It needs to be terminated to a reasonably strong ground. Beyond that, the borehole can sustain the stability by itself with the help of support fluid. Now, in case of permanent liner, when you are passing through relatively longer layers of loose layer or highly compressible layer, then you need to have a permanent casings for a longer depth until it is stable. So in that case, you put casing by casing, jointed segmental manner, and do the weldings. And after this termination is finished, then you have to start for the boring. So in this process, what you do, ensure the point with this pile point with respect to the survey, this casing should be vertical. There is a limit for the verticality, 1.5%. It should be in the right position. There is a positional deviation tolerance also allowed. Then ensure proper welding of the plates, thickness of the plates. Normally it starts with 16 mm, 6 mm, could be 8 mm based on the diameter and the stiffness required. And then proper welding of the plate, you need to have a qualified tested welders, as well as your welding procedure needs to be verified before you start the welding. So we have a systematic process to qualify the welding procedure through making a test plate. That is to be done first before we go for the full scale welding. And ensure the length of the liners, up to which depth it is driven, that should be recorded. then starts boring when the liner is fixed or your temporary casing is terminated, you start boring. This is normally in this time you need the help of the support fluid. Purpose of this is to stabilize the sides of the borehole so that it does not collapse in spite of external water pressures. So the normal support fluids we use commonly is the bentonite or a polymer. Bentonite is a clay minerals. They have got certain properties for the bentonite. It needs to be checked before we use. Otherwise, in case of supporting the sides, it may destroy. So in the process, what do you checks? You see the quality checks on the right side. Checking of the borehole positions, verticality, ensure the calibration of the automated depth meter. If you use the depth meter of the boring rig for the depth measurement purpose, then pH of the various parameters of the support fluid. I will show you in the next slide in detail about the properties of the support fluid, which plays a significant role in stabilizing the sides of the borehole so that your bore is stabilized, clean. So these are the two types. Bentonite, we need four properties need to be verified: viscosity, pH, liquid limit, and density. Liquid limit, of course, we check at the material selection stage, not during boring or on the field. On the field, you need to check viscosity, pH, and the density. So it is 30 to 60. Now, based on the porosity of the layer, the viscosity will increase. So as a general practice for the porous layer, granular layer, it could go up to 50, 55. For clay layer, it could be less, 30, 35. Similarly, if we use polymer, the fresh polymer could be, the properties are viscosity, pH, and density are given. Sand content is not need to be measured the fresh stage, but sand content required to be measured when you start the concreting. The borehole fluid needs to be checked for the sand content. Now, cleaning of pile toe, this most significant, most important part of the pile installation process. So once the boring is over, if you are using the rotary rig, with the help of cleaning bucket, it needs to clean the bottom. Once the cleaning is over by the bucket, then you can run the fresh bentonite circulations to bail out the debris, contaminated item at the bottom of the borehole by recirculations. Another technique of cleaning of the base could be by the airlift principle, where you put air at the bottom of the hole, where it reduces the specific gravity of the borehole fluid at the bottom, it comes up. But it requires proper care. How much, what should be the flow of air, that requires an experience in case of especially in granular layers. Now, while you are checking the completing the base cleaning activity, there are quite a few significant indicators are there. So in case you are using the bentonite as the support fluid, then the sand content should be less than 4%. And the density of the fluid should be less than 1.12 is with respect to Indian standards. For polymer, sand content should be maximum 1%. Now, one thing to be noted, this concentration to be checked from the sample collected at the base of the borehole, from the base of the borehole by a sampler. There are mistakes in collecting samples sometimes from here and there, either from the top or from the middle, but theoretically it should be collected from the base of the borehole to check these concentrations and conclude flushing or the cleaning activity. Now, once you're satisfied with the cleaning of the base or the toe, then you are ready with the lowering of the reinforcement cages. For longer pile, cages will be in segments. Segment to segment, you join by the proper welding. Lower the cage. Cage should have the cover blocks all around, sufficient numbers so that it maintain the covers, and both in circumferential direction as well as longitudinal directions. Now, while you do this activity, your checkpoints could be the cage fabricated as per the drawing or as per the schedule, bar bending schedule you have made. The number of bars are same as per drawing, links are same as per drawing. Then the joints are properly welded so that it takes the load. Spacing of cover blocks should be adequate. Proper lapping should be maintained as directed or as specified. Do the welding preferably with E7018. Now the last phase, we are coming to the last phase of the last stage of the installation process, the placement of concrete. The whole success depends on how well you are able to place the concrete. So once you now remove the tremie head and add the funnel at the top, as you see in the photographs. Now there will be a plug at the bottom of the hoppers. First you fill the hopper, then pull the plug so that the concrete rushes down the tremies, goes down and replaces the latent scum at the bottom and takes the position. So first charge replaces the bottom scum if any left after flushing. The good concrete takes the place and the contaminated concrete comes at the top. That's why I call it the replacement process. Subsequently, you keep on pouring the concrete and terminate and cut the tremie, remove the tremie as the concrete shaft develops with respect to time and the pouring of additional concrete. Now, in this process, quite a few checks are there, which is extremely critical. First of all, the mix delivered at site must be an approved one that should be verified through the document available with the concrete transporting equipment. Slump should be at least 150 mm in the upper side, 180 mm. This is recommended by the Indian standards. Preferably, I should say it would be 180 to 200 would be preferable. Temperature of concrete, there will be certain restriction on that. As a good practice could be 32-degree maximum. The higher the temperature, it will stiffen quickly. So you will have less time to complete the pour. Another thing, when you put the tremie in the boreholes, how much should be the gap at the bottom of the tremie? Or it will touch the bottom of the borehole? There may be confusion. So it will not definitely touch the borehole because then concrete will not be able to pass out. So there should be some gap between the tip of the borehole and the bottom of the tremie. As per the good practice, we should keep it equal to the diameter of the trim. Keep it in mind that it should be equal to the diameter of the trim. Normally, we use 250 millimeter trim for the larger diameter piles. So the gap should be 250 or 300. So that in the first discharge, it replaces the scum, concrete fills the place, and the concrete trim remain embedded. If you keep the gap too much, then the concrete will fall into water. As per the trim replacement process, the concrete should be placed in, should not be placed in water. So the gap should be equal to the roughly the diameter of the trim. Now, while you are continuing the concreting process, your shaft is developing, you need to cut the trim at equal intervals. If you keep the trim embedded more and more into the concrete, you will face problem in the replacement process. The trim get choked after some time. So the guidelines is keep a minimum 2 to 3 meter embedded into the concrete so that accidentally it doesn't come up. But on the higher side, let us not exceed 8 meter. 6 to 8 meter, you keep it, then again cut the trim, then again pour it. Again, when it reaches 8 meter, you cut the trim. So don't try to keep it embedded 10, 12, 16 meter. Sometimes it is possible, but not recommended at all. And finally, our purpose is to get the good concrete at the cutoff level. So since there are some latent scum at the bottom of the pile, which has come up after the first discharge. So to achieve the good concrete at the cutoff level, you need to discard some more amount of concrete beyond the cutoff level. So that depends. There are various specifications that there, but minimum 600 mm let us keep for the when the cutoff level is below 2.5 meter. And some specification says flat keep 1 meter extra, but for the larger dia pile, keeping 1 meter extra may not be required. So that can be verified through different trials. See how good concrete you are getting at 500 mm, at 800 mm, at 1 meter. You can standardize that site as well, but there should be some minimum criteria. So these are the various checks at the concrete placement stage. And you face a lot of problems if all these things are not maintained. There are people who gets guided by the flow instead of slump, because slump is quite indicative. In that case, flow could be 550 to 600 millimeter while you are placing concrete. And this concrete necessarily is self-consolidating type, because you are not able to vibrate it by taking the trimming up and down. We are vibrating the concrete, we are compacting the concrete. So it should be self-consolidating type. And the retention should be higher. Say your placement time for concrete is 3 hours. So the retention of concrete should be maintained at least until 3 hours. The slump or flow should not fall below 150 even after 3 hours for the first charge. So the concrete should remain workable until placement is over. After some time, the initial set should start. If the initial set starts earlier, then you will face problem in replacing the concretes of the subsequent batches. Now, once the pile concrete is over, then various checks and balances we have gone through during the process. Then even up in the completed pile, we have another level of checks. So one of the popular tests is the pile integrity test, where we can check the health of the concrete shaft, whether there is any major voids, cracks, discontinuities, etc., or what about the consistency of the pile shaft. So this can be done by the pile integrity tester. Various codes are there, Indian standards and ASTM are also there. Various projects suggest various quantum of such tests, but nowadays in major projects, we are doing 100% piles under PIT. So this is a quick checks of the concrete shaft. Now, there's another test called cross-hole sonic logging. So this is a further improved one, where you can see the its defects, location of the defects, and the extent of the defect in a more better way. This is another called cross-hole sonic logging test, where we need to insert 4 pipes in the pile before you cast. So this is one of the limitations key. This requires advanced preparations. You need to identify in advance which pile you will do the cross-hole. It could be, the quantum could be 10% to 20% for any site, but it requires advanced preparations. And these pipes could be of steel or PVC. So, and get the report. Report can be reviewed to see the satisfactory nature or any discrepancy, and you have to take action accordingly. At what level it shows what. Then this is one important test, that vertical load carrying capacity test, compression test of the pile. The pile is designed for a certain capacity, and during the course of construction, a certain number of piles are tested for the workmanship, whether the people are adhering to the right workmanship or not. So there are some random tests where we put 1.5 times of the design load on the pile and see the deflections on pile height. So normally the acceptance criteria I've written at the bottom. Maximum settlement is 12 mm for 600 pile. And in case of pile diameter beyond 600, 18 mm or 2% of the pile diameter, whichever is less, is the acceptance criteria. If the deflection within this limit, it is okay. If it is exceeding the limit, it is not okay, requires further review, designers' recommendations about the next course of action. So the test is arranged in the form of a cantilage, where there's a primary girder, there are some secondary girders to set a platform, then there are dead loads on the top of the platform. Dead load is normally 1.25 times higher than the reaction that you need to put on the pipe. In that way, you have to put it. And the guidelines are there in the Indian standard course, how to maintain the load, how much time you will maintain, and accordingly record the displacement, and finally arrive to the acceptance criteria. Now, all these inspection tests that we have discussed in a little bit earlier can be formulated, can be planned in a formal format, what in industry we call it inspection and test plan, which we normally do it in Excel format, which includes all the necessary checkpoint, at what stage this check is to be done, what is the specification says about this, what is the acceptance norm, at what interval I should do this test, and who will do the test, who will do the inspection. All these things are put in the tabular form for the guidelines of the activity engineer as well as the inspection engineers. And at each stage, you inspect it, capture the data. If it is okay, satisfactory, fine. If it's not okay, you need to have some corrections to go before you go to the next step. So this is one format that we are discussing, the form inspection test plan. By various stages, as just now I have discussed, put it in this format. So in the column wise, if you see the component operation means stages of work: survey, liner driving, boring, concreting. These are stage. Characteristics means what are the various things you should do. In case of boring, you check to support fluid characteristics, you need to check the depth. These are the characteristics. And type of checks, field checks or laboratory checks, frequency, at what interval, how frequent you should do this test, which reference document I should follow for this particular parameter or particular characteristics. That is to be noted over here. Say in case of boring, let us go to row number 3, viscosity of freshly prepared bentonite suspension is the characteristics. Type of check is field inspection. Frequency of checks, random. In which code or standards I will find guidelines about this 2911 part 1 section 2. What is the acceptance norm? Viscosity of freshly prepared bentonite suspension 30 to 60 seconds. Now, who will perform the test? Contractor. Who will witness the inspection? Client or the consultant. Then in which format you will record all this observation, in which format you will record of the inspection matters, that is also written in the another columns. So this is a formal formats widely used in the construction industry to jot down all the characteristics for the inspections and see the acceptance norm, whether it has passed or not. If passed, go to the next stage. If it doesn't pass, then take some action, satisfy it, then go to the next stage. And where you see the, frequently if you see the variations on a particular case or a particular characteristics, then you need to ponder in depth why it is happening time and again. So that requires special analysis, what we call the root cause analysis, using some quality tools. It could be brainstorming, it could be fishbone diagram to arrive at the root cause so that something happening frequently could be minimized. So all these things what we discussed, I put it in the tabular form just to show it as a formal record, as a ready reference for the activity engineers and the inspectors. This concreting, all these parameters we have given: concrete mix, compressive strength, slump test, shaft build up during concrete pouring, overflow, how much you should do the overflow, temperature of the concrete. Then finally, last 2 rows, you see the vertical load test and dynamic load tests. Now you see the in this slide, we will show you the common observations or non-conformities in board cast in place piles. What are the symptoms we see commonly on the field? There are reasons behind it, but still just for a reference, say sometime we have seen good concrete not available at the cutoff level. We have done piling, then post excavation, I find at the cutoff level, still latency is there or the good comp is not available. So what could be the likely reason? The improper estimation of the placement to build the required shaft. Or sometimes what happens when you remove the temporary casing due to the loose soil all around, the concrete slumps more than estimated. So it goes down because it goes sideways, and ultimately the height of the shaft comes down, uh, causing your estimation, proving your estimation wrong. Reinforcement necking. Sometimes you see after excavation or through a PIT, the information comes if there is a necking at 10-meter depth, 19-meter depth. So what could be the probable reasons? Insufficient cover blocks broken during lowering of the case due to poor strength. When you lower the case, you strike here and there and the blocks gets broken. Ideally, the strength of the cover block should be, the mix of the cover block should be similar to the concrete of the pipe. Presence of soft clay, which is not in your control, could be a probable reason for the necking. Anomalies detected PIT, like the joint crack, poor concrete porosities. This is purely due to the poor handling of the concrete during the placement process. That means there might have been interruptions during the concrete placement process. There is a delay, concrete early status started, compaction could not be done properly, it's concrete flow, it's not self-consolidating types, so enough compaction is not done. Choking of tremie piles during placement of concrete. This is another common phenomenon. So this is the classic case when your tremie embedment is high, the replacement process get disturbed. Choking will be the symptoms. Then initial set of concrete started. That means there is a delay in the placement process, or the retention of the concrete is lower than the timeline that you estimate for the placement. And sometimes there is a leakage in the tremie joints. The water enters through it. That also causes clogging. So tremie segment joint must be leak proof. Then bore collapse during boring. This also happens in granular soil layers. We have faced these problems. The support fluid takes the lead role in this particular case. Support fluid viscosity, mud weight is less than required. Interruption during boring. That means there is a long waiting. Highly porous layer, the granular layer, the coarse sand, high water pressure, standing water level higher than your borehole fluid level. Borehole fluid level is lower than the standing water level. Poor quality of support fluid. Poor quality, I have shown some properties of the support fluid. If it does not matches with that, so you can't expect the performance as you desire. Excessive settlement during compression test of working pile. It's purely related to the base cleaning not done properly. There could be cracks, joints in the concrete shaft. Variation in soil strata, then something you assumed at the design stage, actually you didn't get this. It's poorer than what you assumed. That could be one of the reasons. But the base cleaning in this case mostly responsible, as we have seen from past experience. Liner got buckled during driving. This is a pure case when the thickness is lower than required. When you put the excessive driving efforts, a bigger hammer, higher drops. Sometimes we have seen this stiffening at the bottom. You need to put a stiffening in terms of a shoe, wrapping of additional plates, which is not provided in sufficient. quantity, so you could not take the strength. So it gets distorted. So a little bit drivability analysis is required to be on the safe side. Sometimes we have seen the reinforcement case top. After excavation, I find the elevation of the case top is lower than required. That could be a problem on this higher bore depth. You have done higher than specified. It has gone down. Sometimes anchorage, we keep the cage hung on the casing. If the anchorage gets broken, the cage may go down. Incorrect lapping. If you put more lappings, the total length of cage is likely to be smaller than the actual. So it goes down, the top goes down. So these are the likely reasons anyone may fit or may not fit. So for the exact analysis of the reason, you need to have the sampling, additional entities, the analysis of the data, sometime alone or sometime in a group, to find out the exact reason so that the repetitions can be stopped. Now we conclude. You see, the construction of a durable and sustainable RCC structure. Nowadays, we always talk about sustainable construction where the intended service life is higher and higher. So now 100 years, 120 years, like that is the intended service life. So the quality assurance plays a significant role in assuring the intended service life of the structures. So it requires meticulous planning, good infrastructural arrangement, that you should have an updated instrument as well, modern plant and equipment, competent supervision, trained and stringent quality control to succeed. And the key parameters I should focus, which needs special attention to ensure a good pie, is stabilizing the borehole throughout the entire operation, cleaning of the pile too, and the placement of concrete uninterruptedly through training. These three things are the key parameters or the key factors to your success to have a good pile. Quality control must be effective and demonstrated by a trained and experienced group of engineers at each stage of pile installation process to assure product quality for the intended service life. So with all these, I come to an end to my presentations. Now we can have some question and answer session on the part we have discussed.
Thank you so much, sir, for such an excellent presentation. So there are so many questions in the chat box. So depending upon the time, we'll try to cover as many questions as possible.
Yeah.
So the first question, is there any Indian standard or American standard available for polymer specification?
Yeah, polymer, we have the API, section 13 is for the polymers. And for mostly we depend on we go by the manufacturer's specification as well for the polymers.
Okay. So the next question is from Mr. Deepankar. How to ensure calibration of automated depth meter? Is it required at site for calibration?
Automated depth meter is fitted with the rig actually. I do not encourage going by the automated depth meter for the depth calculation or depth measurement. It is recommended to go for the chain sounding to find out the actual depth of the borehole. Depth meter could be an secondary instruments. Normally we don't use, but the calibration can be done because any instrument can be calibrated. It has to be done through the manufacturer of the rig supplier.
So the next question is, what is the mechanism of fluid mud with the soil? How much time will it hold the walls against collapse?
Pardon, once again, please tell me.
What is the mechanism of fluid mud with the soil? How much time will it hold the walls against collapse?
Yeah, this is very difficult. There is no calculation like that, I think. Only thing you have to keep watch, continuous watch, that you are able to sustain the side borehole or not. There is an indication that your boring will not progress much if it keeps collapsing. And if it keeps collapsing, you need to increase the viscosity of the fluids step by step and see whether it has stabilized or not. Normal guidelines, you see, for the good practice, between completion of the boring and the commencement of concreting, you should not spend more than 6 hours. Completion of boring to commencement of concreting should be within 6 hours. And if you use good quality bentonite or the polymers, it all satisfies these. But in aggressive layers like a coarse sand layer, of course, there are challenges where even high viscosity to the range of 55 may also give you trouble. In that case, the reduction of times between the stages is the critical factor. You need to minimize as much as possible.
The next question is from Mr. Ramveer Singh. What can be the alternate solution to prevent the borehole collapse at deeper depths if the borehole collapses even after using the bentonite or polymer?
Yes. First of all, you should try to stabilize the borehole with the help of support fluids. If at all it is not possible, really it is not possible, then it's a pure case of lining the borehole. That means you need to advance the casing, permanent liner. You need to advance the permanent liner until that depth which you are not able to stabilize. Beyond that, you go against.
So the next question is from Mr. Sandeep. How to confirm where we have to use bentonite and where we have to use polymer?
Both can be used actually. People are nowadays uh, inclination more towards polymer because of its environment friendly in nature, as well as the quality of the product is likely to be better in case of polymers because of the good base cleaning and stabilization of the sides. There is no clear-cut demarcations where bentonite will work and where polymer will work. Both will work, or rather polymer will work better. Since it is environment friendly, it is more encouraged. We have seen the pile base cleaning is better in case you use polymer. That's why you might have noted that sand content, when you use polymer, the criteria says it should be below 1. But when you are using bentonite, it says below 4. So the cleaning of the pile base is better in polymer. So you can try it, but there is no clear-cut demarcations. Both are used as support fluids.
The next question is from Dr. Sunil Basarkar. When polymer is used as stability fluid, would you recommend flushing?
This is a common query I have seen, but still flushing is advisable because there is always a gap between your completion of boring to the commencement of concreting. If you are using a 50-meter long piles, jointing of the segmental cages, it takes 8 to 10 hours. So it's quite a big time lag. So the flushing is always advisable before start of concreting, even though it is polymer. It will take less time,
So the next question is from Mr. Rajan Peter. Use of ultrasonic monitors help in monitoring the verticality and shape of the hole with high accuracy. Why it is not being used in piling in India?
Yeah, piling we have not tried. We use in case of trenching diaphragm wall, we use this type of monitor where we check the verticality as well as the shape of the uh, trench. But in a pile, it is yet to be implemented. But there are very rare cases where we have seen the pile has went out of tolerance. They're very rare cases. So the necessity has not risen in that case. Very rare cases of the pile went out of tolerance in case of verticality. There may be some cases of displacement here and there. It's more than tolerable limit. The inclination more or less meeting.
So the next question is from Ms. Shweta. Since concrete is not cured in cast-in-situ process, so the compressive strength is not attained fully. How can we overcome this?
Concrete, when the concrete, you take sample at the time of concrete placement, and when testing at the due date, you see the strength of the concrete fallen much below the characteristic strength, then there should be designer checks whether with this strength the pile still can survive or still can be acceptable along with the other piles in the group. If it is not acceptable, then there is a question of additional pile installations. Otherwise, it can go as it is. Due to the lower grades, it can be dealt contractually. Technically, it could be acceptable on designers' recommendations.
The next question is from Mr. Pankaj. If concrete pouring was done above 32 degrees in pile and some observations comes from the client side, then what will be the test to be done to close observation?
I think you see the in case of temperature, it is not that critical that in case of 32, if it becomes 33, the quality of pile will be haywire. It's not like that. It's the case of discipline. The 32 ki jagah, don't put 33 in case of 32, but in the rare cases, it doesn't matter. 32 is a standard practice. There are cases where the guidelines says it should be below 30. There are cases where it says temperature should be below 25 in case other than pile I'm talking. So they 1 or 2 degree this side, that side, sometime in exceptional cases does not require any action.
The next question is from Vivek Sama. How commonly are anomalies detected using the PIT test?
In PIT test, anomalies are rarely detected if you follow the good process. I have seen from my experience, it's mostly you see the uniform shaft through the PIT test. Unless things are handled in a very poorly manner, the PIT test always passes.
One comment from Mr. Alok Bhaumik. Excellent presentation. Very, very important for those in the field as well as those who are planning and designing. So another next question. How to collect bottom samples of polymer slurry from pile bore bottom?
Yeah, there is a bottom sampler. Actually, I have missed it to show in the presentation. I had a photograph in my last paper, the DFI last year submission. I have shown this sampler. I was thinking I'll put it, I have forgotten. So there is a sampler where it goes in the bottom open condition at the bottom, then water get into this and bottom and top gets close. So a bottom sampler is a special device where you have to collect the sample from the bottom.
Sure. Next one is from Mr. Sanjay. What is the alternative solution to prevent loss of bentonite slurry?
There could be loss of slurry during the boring process. You will see there could be possibility of slurry loss. At that time, you see the head of the fluid comes down, and there is a possibility that outside water is higher than the boral fluid head. So this is a critical issue. You can check the quality of the bentonite for the cake formation. This is one of the indicators whether really it's a case of quality of bentonite. The cake formation is adequate or not, there is a special test. From there, you can find out whether it is performing as desired or not. That is the only solution. If it doesn't, if qualitative problem, you replace it. But in porous layer, there will be some losses which is more than fine grained layers. But if the quality of bentonite is of good quality, these losses are minimal. It is not like that the head goes down abruptly, you're not able to bore it. There are very exceptional cases. I have not seen, but there are losses, which is more than normal that we have seen. So cake formations may lack in that cases.
So one last question, sir, from Mr. Alok Bhaume. Can we use raker piles for both cast-in-situ piles? If yes, up to what diameter and length? Any practical case where raker piles are used?
Yes, raker piles are used. Actually, raker pile can withstand a larger horizontal thrust. Say for in case of JT, the horizontal load comes when the vessel berths, during berthing of vessel. So there are examples of installing raker piles in case of marine structures like jetties. It could be a RCC pile, it could be a steel tubular pile. RCC pile in rake installation is difficult, but in steel pile it is easier to install. But there are quite a few examples installing the raker pile in case of jetties.
One more question from Mr. Mohan Ramanathan. Do you recommend using only self-compacting concrete for piles?
Yeah, cell compacting can be done. Rather, the specification is such that it is neither cell compacting nor normal. The Indian standard is somewhere stands like that. But in the international scenario, it should be self-compacting concretes. The maximum size of aggregate should be 16 mm. It's preferably like that. But we try with 20 mm aggregate with the higher flow, about 500, 550, or in terms of slump around 200. It works. The self-compacting is no objectionable, rather. Okay, good.
So this marks the end of Q&A session, sir. Once again, thank you so much, Mr. Tarun Kumar, for accepting our invitation and delivering such a wonderful presentation. Thank you so much, sir.
Thank you all those who attended. See you next.
Okay. So just to give a brief about the upcoming DFI of India programs. As most of you are already aware about, the DFI of India is conducting its 13th annual conference in Goa, the party capital, during 19 to 21 September 2024. So several national and international experts like Professor Alessandro Mandolini, Professor Madhav, Dr. Venu Raju, Mr. Alan Marr, and Dr. C.R. Parthasarathy are delivering keynote presentations on several topics during the conference. And the highlights of the conference include, like as I said, keynote presentations, and we'll have a special session on the topic, tall building foundations. There will be an entire session dedicated to this topic, and we'll have a Women in Deep Foundations program. So several paper presentations, and several Indian and international organizations will exhibit their products and services during the conference and networking. And there will be several awards and lifetime contribution awards and much more. And support for the conference is very huge from the industry. So we thank all the sponsors and the exhibitors who has been constant support to DFII of India. So I request everyone to join us for this conference during 19 to 21 September. So this marks the end of Groundwork 2024 Session 3. Once again, I thank one and all for joining us today for this webinar. So we request you to join us in the upcoming Groundwork webinars. Thank you so much.
Close. Without introduction.